Okay, so any of you sitting in here, I'm just going to live stream this so that when people ask later, they've got it. We're going to look at some error analysis. And maybe before we do that, I'll just remind people, uh, this was the circuit we're looking at today, right? And so we figured out that for this particular circuit, if I measure these two voltages and know this resistance and the lengths of the wires, I could figure out voltage 2 this way. I could figure out the current that way. And this is how I could get resistors 2 value, right? I know this voltage from doing some math. I know that current from doing some math. However, how does that affect the error analysis? So let's do a screen share of a spreadsheet. This is a fake spreadsheet I'm making up here. So these numbers don't mean anything, but here we have it. So go ahead, Min, since you're here, how would I get the current?
Okay. To get the current, I can find the voltage across the resistor and divide it by the resistance of that resistor.
So which cell should I click here in the?
It's V1 divided by R1.
Is that going to get the job done right there?
You need to get the to use the F4 function on the R1.
Yep, there we go. And so that will get the current right. And then how many sig figs do you think that number should have?
I guess 5 or 6.
How many does this one have?
Oh, 3. So
and how much does this one have?
3.
So probably
3.
Right, good. So we can fill that down here. So there's our currents. Does that make sense, Min? Do the numbers make sense in my fake data set here?
Yeah.
As the length of the wire goes down, what's happening to the current?
As the length goes down, the current should.
Is it going up or going down?
It should be going up.
Yeah, and that makes sense, right?
Yeah.
Okay, good. So now how do I get the error here? So this, let's go to the board and look at our formulas, okay?
Yeah.
So give me a second. All right, and so now I'm gonna have to erase what we've got here, but that's fine. Whoops, I lost my formulas here. We said, oh, we've got I up there. We said that was one formula, and we know that delta V2 was equal to, what was it, voltage E minus voltage 1?
Yeah.
I think that was the color coding. Now these are delta V's, and you know, for the purposes of lab, if you left off the deltas, I'm fine with that. So it might be easier just to say V2 rather than delta. Just be consistent all day. All right, and so then our last formula was this. What did we say? We said that R2 was equal to, what was it? V2 above I? Is that right, Min?
Yeah.
Thank you. Okay. So now we're trying to figure out this one, right? And we want to get the error in I. Well, that's not too bad. I know that the error in I is equal to I, the value I got, times the square root of the error in V1 over V1 quantity squared plus the error in R1 over R1 quantity squared. So far, so good?
It's kind of look like the magnitude.
Yeah, so this is in the error analysis handout, but it's easier just to see it live. The idea is, what if you're off by a small percent here? So if you're off by a small percent here, this would give you a percent error effectively. It's actually a fractional error, but it's very similar. This one right here would give you a percent error in measuring the resistance. So Ryan, I know you just popped in. I'm live streaming this just so I can explain the error analysis to everybody and just let them watch the video, okay? So I do want to point out here, in order to make the units look right, oftentimes people write this like this. The percent error or fractional error in I relates to these other fractional errors. However, in our data sheet, if you need the error bar, we got to cross multiply, and this I right here is commonly forgotten. So now, Min, do you have that written down on your paper or something?
Yep.
Okay, so I'm going to ask you to tell me what to type in Excel now, okay? So let me go back to the Excel spreadsheet. Okay, so what would I type to get DI? Equals, I'll do that for you. Okay, what was the equation? Do you have it there?
Yep.
So what do I need to do?
So it's gonna be I times square root of.
Okay, and then just so I don't lose track of my parentheses, I'm going to put them in there and go up to here. Give myself some extra space, right? Yeah. So now what do I need to do?
It's gonna then we're gonna have dv2 over it's dv1 over v1 square plus dr1 over r1 square.
Whoops. Right?
Yeah.
And now I'll just get rid of some of these extra spaces. And so hopefully we can read that. How many sig figs should you have on an error calculation? What's your gut tell you?
It's going to be the same like the other one. So it's going to be 3.
1. Error calculations, you usually only keep 1 sig fig. Exception, if the first digit has more than 1. So now take a look. This one says your measurement of the current should be off in the 1,000th place. This makes sense with what we expect from sig fig rules, so this seems pretty consistent. It's not always going to match up. The DI calculation is going to be better, but if I roll this all the way down, oh, what did I forget?
Oh, you forgot to use the F4 on the R1 and the R1 as well.
And so we see that, notice they're not all exactly the same, but they're approximately the same. In fact, here it looks like they're always about 1%. Do you see it? If I stick on the next sig fig, it's about 1% all the time. Okay, whatever. So that's cool, but now we know it. Now, obviously, I didn't put the units on here. I would expect students to do that. I didn't do the formatting or the units on any of these. I did do it on the first half dozen or so. But yeah, okay. So now tell me what's up for V2. How would I get V2?
You can get V2 by you use the V of the battery and subtract that with V1.
Okay, estimate how many sig figs do you expect?
3.
Yeah, now notice that when the number ends in a 0 like that, you have to go in and manually fix the sig fig. So it hides the trailing zeros, so you have to remember to put them back in. Also, look down here. These are actually all the sig figs you get, right?
Yeah.
So they're all about 3, except for maybe the last one. All right, so now how do I get the error in V2? Let's go to the board. Okay, so in this case, V2 was obtained this way. So I know the equation for V2. Now we're looking at this one, right? So the error in V2, there's many different ways you could do this, but we're going to assume that these two errors, wait, what if this one's off and that one's off? A worst case scenario would be add the two errors together. So some people might say do this. just say take the error in this voltage and add it to the error in the other voltage. That's a worst case scenario. So notice something very different here. When you're doing a subtraction or a multiplication, the errors just add up. When you're doing a multiplication or a division, we get this complicated formula where the fractional errors add up. Now, in order to, it turns out we can add these errors in quadrature to get a slightly more reliable estimate. It turns out just adding up the errors is an overestimate. By doing it this way, we actually get a best estimate for this. So this is the technique that I would suggest that we use since it's easy to do in Excel. Do you have that formula written down?
Yep.
Ryan, are you paying attention to this or no? Let me see. I don't know if he tuned out. Oh, he took off. Oh, my bad. Okay, so let's go ahead and Min, I'll let you, or does anybody else want to chime in? I'll just see if anybody's actually listening. Okay, let's just you and me keep working, Min. All right.
Okay.
All right, Min. So what am I going to have to do here?
Okay, so it's gonna be square root.
Don't forget that equals square root of
The square root of dv2 square plus dv1 square. Oh wait. These
right?
are dv e square plus dv1 square. My bad.
Right?
Yeah.
And so we see we're off. Now this one, because the first digit is a 1, how many digits should I keep?
2.
2, excellent. So errors, you usually only keep 1 digit. If the first digit is a 1, in physics problems and engineering, we often keep an extra digit. Huh, they're all the same. Okay, that's because the delta V's are all the same. And these are all, so that makes sense, doesn't it?
Yeah.
Okay, so finally we're up to the last piece, okay? So I'm gonna see if you can explain this to me and tell me which type of formula applies. So let's go to my whiteboard here. So now we're wanting to figure out this one. So would I use this first type of formula where I do the square root of the fractional errors, or would I use this one here where I just do the square root of the errors? What do you think?
I would use the first one.
Exactly, because it's a multiplication division.
Right.
And so, and it turns out everything we've done, nothing's had any weird powers. If you did have a power, it turns out there's a way to modify this. So if you get to a lab later where you need powers, let me know. But so that said, I'm going to put this down here a little bit. So now for this one, tell me what I should write, Min.
Okay, so it's gonna be R2. We're gonna get R2
Excellent.
times square root of dv2 over v2 square plus di over I square.
And I think you could figure that all out from here, right?
Yeah.
And then punch that in on your own in Excel. What do you think? Kind of making some sense?
Yeah, definitely.
If you're curious where these come from, all that we did was we took and I'll be right with you, Louise, okay? All we did was take derivatives of these. And that's how these formulas get generated. We don't have time to explain it all now, but in an upper division lab course, they might explain this with derivatives and expect you to actually do something more meaningful. Good enough?
Do we need to explain why we use the formula in the report, or we just gonna?
No, this you do not need to explain, but that's how you do it. And so this is the only calculation I'm expecting that you do. So if you've got it, people are going to start asking me about this now. I'll just leave this up on the board. Is that cool?
And this is all we need to we need for the error analysis, right?
Yeah. Okay. And so actually, I'll show you a couple more things. Let's make sure. So do you agree that you know how to get these numbers here and these numbers here? Oh, whoops. Sorry. I didn't screen share it. Sorry. My bad. And Louise, thanks for being patient. I'm just trying to get this live stream done so everybody understands. So do you understand how to get these sets of values, Min?
Yep.
All right. And so I think I'll just do this one. This one should be this divided by that, right? I don't know how many sig figs, so I'll just assume 3 and worry about it later. Okay. And so maybe I'll go like this. I'll just say, I'm going to make up some numbers here. Okay. Just so I have something. All right. So I don't know if these are the right numbers. I made them up. Okay. Now, that said, what do you need to do? You need a plot of L versus R. These will be the error bars vertically, or wait, L is horizontal, isn't it? So these would be the error bars horizontally. These would be the error bars vertically. And then you can use the line ST function. So because I've got everything kind of all over the place, I might do this. I might make a copy of this. Maybe I'll do a copy of this actually. And then you notice the numbers change. So what I would do is actually say this is equal to that and say this is equal to that. That way I can reference them in multiple places. And then what I can do is I can highlight the L, press Control after it's highlighted, highlight the R. Whoa, I need to insert. Oh, I got to get rid of the zoom. Okay, there we go. So highlight. Okay, there we go. Insert a scatter plot. Okay. Zoom. Did I insert that? There we go. All right. Then you can obviously label these and do everything. I'm going to change the font right away because then I can update this. You can add the following pieces. We can get your axis titles, and you can also add in the error bars. For the error bars, what you can do is you can actually, let me make this smaller here. Sorry, Zoom's killing me. If I want to, I can go to right click on these error bars and I can format them, right? And remember, my vertical error bars are coming, whoops. My vertical error bars are not some fixed value, they're a custom value. So I can specify them by going into here. The positive error value and the negative would be this, wait, this is the vertical error bars, aren't they? Whoops, that's wrong. So I need these numbers. So that gives me the vertical error bars. Okay. And now I can get the horizontal error bars. That's going to be these values, which notice these happen to be 1%. So maybe I'll just go into here. You could select them again, or you could just say it's 1% in this case. And now when you can't see the error bars, you can come into here, marker options, none. And then maybe before I do that, I want to add a trend line. Display the equation on the chart. I've got this here. I'm going to now get rid of those markers. So now I can see the error bars better. And again, there's going to be something that you're supposed to do called the line ST function. So I guess I'm showing you everything here, but that's fine. I'd rather have you learn this, and then the next lab, I'm not going to show you everything. You're going to have to remember it. So equals line ST. Now this is in the lab manual appendices, but we need to highlight, notice it tells you first highlight the known Y values. Well, that's the resistances. Then we're going to highlight the known L values. Got it. And then I believe you write comma true, comma true. And then what do you have to do here? You have to slide this over and then slide this down. And then I think you hit F2, Control Shift Enter. Yeesh, that's a lot of crap to remember.
Yeah.
But what is this? This right here is the slope. See it? This number right beneath it is the error in the slope. And so then if you need the error in the slope for doing your calculation for resistivity, you've got it. Is that making some sense? I don't know if it does, but I'm going to leave that. Yeah. Oh, let's stop the screen share for a second. Okay. And let's see here. I see where, oh my gosh, what is going on here? Okay. And so I know some of you are waiting to ask questions. I just want to get that done. Remember that somewhere in the end, you're going to have an equation like this for rho, and the slope is going to be inside of it, right? Well, you need the error in the slope to figure out the error in the resistivity. That is what I was trying to explain right here. This piece of information right here and right here, this gives you the slope and the error in the slope for doing your resistivity calculation. So, all right, now I'm going to stop the live stream, and you've got that if you need it.